Hello friends, hope you are doing well. So welcome to entirely new series of Staad Pro. In this series, we are going to learn how to design and analysis a truss in Staad Pro. So basically, we will provide dead load, live load, and further on wind load on given truss member, and we'll calculate the tension and compression value in each of its member. So let us move to the objective of today's class. So as you can see here, the objective is written to design given truss in Staad Pro and run analysis to get compression and tension values in any of the member. So this is our given truss. In this truss, this P, P, P are the loads, and at the end, as you can see, the load is P by 2. So in this way, the dead load and live load will be acting on this truss. And finally, when we apply these loads in Staad Pro and design this truss, we will be able to get the compression and tension values in each of the member of this truss, and that is our objective. So first of all, what we have to do, we have to design this truss in Staad Pro. In Staad Pro, we will give the coordinate value of these yellow nodes. As you can see, 1 2 3 4 5 6 7 and 8. We have to put the coordinate value of these yellow nodes, and then we have to join each and every node. I will show you how we will do that. And then these black nodes will automatically be created in Staad Pro. We do not have to provide these node values of these black node. So I have already written the dimensions and the value of node. This may vary according to your roll number. Now, take a little glimpse of dead load calculation. So basically there are four components: self weight of truss, weight of galvanized iron sheet, weight of purlins, and weight of bracings. So please be careful about the units. These three units are in Newton per meter square, and this is Newton per meter. So here I have written the way in which we have to calculate the total load, and further this total load will be is equals to 8P. As you can see in the previous slide, every node is taking load P, and these last two nodes are taking load P by 2, and there are total 9 nodes. So the sum will be 8P. So 8P will be equal to 33.85 kilonewton. So each node will be carrying 4.23 kilonewton. These all nodes will carry 4.23 kilonewton, and these ends node will carry 4.23 by 2, means half of the 4.23 kilonewton load. Similarly, we will calculate live load, and a live load carried by each node is 6.08 kilonewton. So I hope you got the point that how we will distribute the live load and dead load on this given truss. Finally, we have to put this load on the rafter nodes. Rafter means this upper part. This upper part is called rafter, as I have already mentioned here. And on the rafter nodes, we have to assign these loads using Staad Pro. So let's move to the Staad Pro and see how these steps are done. Okay, so here is the Staad Pro icon. I am just opening it. It may take little time. Okay, so this is the first screen of the Staad Pro. As you can see here, I have already created many projects. So if you have to create a new project, then go to new, and first of all put the file name here. Suppose I am putting it as Staad1. Okay, then you can browse the location, means wherever you want to save this file, you can select. Suppose I have to select this folder, then click on select folder. Now this file will be saved in that particular folder. And then now coming to units, there are two options, English and metric. Metric basically means the distance will be measured in meters, so I am selecting this one. And after that, go to configure, and in configure we have to select some things, like first of all go to design code, and in steel option select IS 800 2007 limit state design. We will be following this limit state design throughout our truss in Staad Pro. And in concrete, let it be IS 456, and aluminum timber, aluminum US and AITC 1994. It does not matter to us. Then click on OK. Now the job on the first page is done. Now simply click on create. Okay, so in this manner we have created our new file. Now our first task is to put the value of coordinates of that node which I have told you. Here, as you can see, these yellow nodes, we have to put the coordinate value of these yellow nodes to design the base of this truss. Okay, so first of all I will put 0 0 0, then I will put this node number 7 value, that is 1500, then I will put 4, then I will put 8. So I will go in this order: 1, then 7, then 4, then 8. After that we will go for 2 3 and 5 6. So putting the value of node number 1 and 7 instead. So how to do that? First of all, select this uh, cell and put 0 and then simply press enter. Now the second node is 1500, so simply put here 15 and press enter. Third node is in between these two nodes, that is node number 4, and value of node number 4 is, so how to do that? First of all, select this uh, cell and put 0 and then simply press enter. Now the second node is 1500, so simply put here 15 and press enter. Third node is in between these two nodes, that is node number 4, and value of node number 4 is 7.500. So let me put here 7.5, then simply press enter. As you can see, there are 3 nodes on the screen. This is in 3D mode, but we have to convert it into front view. What is the meaning of front view? So as you can see in this truss, if we see from this side, we will get the front view. So basically we have to design in the front view. So what we will do, okay, let's see. Simply go to view, then click here in this area simply, and then click on this icon. As you can see here, it is written front view. So this is the front view. Now let me put the fourth point. Our fourth point is this one, point number 8. So coordinate of point number 8 is 7.5 comma 2.44. So let me put here 7.5 and then 2.44. Okay, now as you can see, node number 4 is ready here. Now let us join these all nodes by our truss member. For that, go to geometry option, further click in this area if this is not highlighted, and then click on add beam. Now there is a beam icon, as you can see, along with the mouse cursor. So simply select this node and join these two nodes. Okay, see, so this is the outline of our frame structure. No. Okay, let's move to the PDF. So we have to create node number 5 and node number 6. This is 5 and this is 6. So I want to tell you that there is one more way to create a node. You can either create a node in Staad by putting these ordinates. Okay, the reference point of these ordinate is this one. This is 0 0 0. Or you can put node by selecting any beam. Suppose I have to put these two nodes by selecting this beam. Okay, so for that, what I have to do? First of all, go to select, then go to beam cursor and select this beam. After selecting this beam, right click and click on insert node. Okay, so as you can see, here are 3 colors: violet, red and green. So what does it mean? It means that starting point of this beam is from the right end, means any distance which will be measured on this beam is from right point. So if I have to insert 2 nodes here on this beam, so the distance will be measured from this side, right side, and not from the left side. So please be careful about this. I have to put length of 2.07 for this node number 6, because in our Staad, end 7 is the starting node, and for node number 5 we will put 4.14 because end 7 is the starting node. If it was vice versa, that is node 4 was the origin node, then we have to put 5.43 and 3.36 as the distance for node number 5 and node number 6. Hope that you have understand. So I will put 2.07 and 4.14. So in the distance, put 2.07 and click on add new point. Then further put 4.14 and click on add new point. Okay, then click on OK. So here we have created two more nodes. Okay, so our next node is these three nodes and these three nodes. So as they are equally intersecting at a distance of L by 4, so we will directly create them instead. Let us see how we will do that. So first of all, select the beam cursor and then select this. Then right click and click on insert node. Now we will have to insert three nodes which are equally intersecting this truss member. So for that, simply put n is equals to 3, means number of node is equals to 3, and click on add endpoints. Then click on OK. Similarly, do for this right side beam. Go to insert node, then click on n is equals to 3, add endpoints, click on OK. Now our task is to join these points to get the actual truss. So for that, go to geometry, click on add beam. Okay, so two more nodes are left on this truss member. As you can see in the figure, they are these, and it is, since it is equally dividing the members, so it is the midpoint or mid node. So how to add mid node? Click on the node, then click on insert node, click on add midpoint, then click on OK, then select this node, click on insert node, click on add midpoint, and click on OK. In this manner, we can put midpoint or mid nodes at any of the member. Now, I suppose, yeah, this member has been wrongly created. So to delete this member, select this and go to delete. Click on OK. Now our task is to join these two extra nodes. Go to add beam and then simply join. Okay. This one is also joined wrongly. So for that, first of all, go to select, go to beam cursor, select this beam, go to geometry and delete this. Okay. Then click on add beam and add a new beam. In this manner, we have created our given truss member. Now our next task will be to put the loads on the nodes and analyze it. That we will be seeing in the next video. Thank you.